Hi everybody, I'm Fred Feldon. Thanks for watching. Gerrymandering refers to drawing boundary lines to affect the outcome of an election. It's been ruled unconstitutional many times by the courts, but to this day it still goes on. The famous image you see here was created when the bizarre shape of a voting district in Essex County, Massachusetts in 1812 was created to favor the Democratic-Republican Party over the Federalists. The local newspaper at the time likened the shape to a salamander, and the word gerrymander was a blend of that word and Governor Gerry's last name. It stuck to this day. So here's a hypothetical example. Let's say each square you see here represents 1,000 voters. It's 5 by 10 with 50 total squares, so the drawing might represent a city of 50,000 voters. You can see voter registration is 60% blue and 40% red. Suppose 5 districts need to be created, each with 10 squares. If district boundaries were truly randomly drawn, you'd expect the blue party to win the election by 3-2, like you see here, right? But depending on how district boundaries might be drawn, blue could win by 5-0. And what if the red party were in control of drawing the boundaries? What if they drew boundaries to give themselves just barely an edge in as many districts as possible, and then crammed as many blue voters in the leftover districts? Blue might win a couple districts, but red could win the election by 3-2. Is that possible? Ta-da! There it is. That's not the only way. There are other ways it could be done, but yes, I hope this shows you it is possible to affect the outcome of an election by drawing boundary lines to favor one party over another, even if they're a minority. Here's an example from our own neighborhood near the college where I teach. A few years ago, the proposed redistricting on the right would have divided Asian American voters, which typically vote Republican. That would give the Democrat, Loretta Sanchez, a better chance of getting elected, which she did. And here's more examples. Do these boundaries look randomly drawn? Does this look fair to you? So let's take a look at the math. Let's focus on, given a district with 2 different parties and the voter affiliation of each, how could boundary lines be drawn to affect the outcome? What's the maximum number of districts one party could win? What's the minimum? Suppose a certain state has 10 representatives and a population of 6 million. Party affiliation is 50% Republican and 50% Democrat. So if districts were randomly drawn, what would you expect the distribution of representatives to be? And what if unlimited gerrymandering were allowed? Then what would the possible outcomes be? Well, if districts were drawn truly at random, you'd expect the distribution to be 50-50, just like the population, right? With 5 Republicans and 5 Democrats. If unlimited gerrymandering were allowed and the Republicans could control the boundaries, well, take the population of 6 million and divide by 10, so you'd have 600,000 voters in each district. To win a district, you need 50% plus 1, right? For a total of 300,001 voters. So if it were possible to draw boundaries and spread out your Republican voters precisely to give them a barely winning majority plus 1, 50% plus 1, how many districts could you do that in? You could do it in 9 districts, and that would leave the Democrats with just a single representative. What if the Democrats were in charge of redistricting? Well, of course, they could do the same thing, which would send 9 Democrats to Congress and only 1 Republican. So now I think you can see how, depending on the district boundaries and how they're drawn, the Republicans could have anywhere from a maximum of 9 to a minimum of only 1 representative in Congress. What if the affiliations were not 50-50? What if, say, 70% versus 30% in favor of the Democrats. Now what are the possibilities? Well, again, if districts were truly drawn at random, you'd expect 7 Democrat and 3 Republican representatives. But what if Republicans were in charge of redistricting? How much could they increase their number of representatives? Doing math in a similar way we just did in the previous example, they could increase their number of representatives to 5, and that would tie things up. Big difference. What if the Democrats were in charge? What's the minimum number of Republicans they could get that down to? None. The math here shows the Democrats could easily spread out their voters to control every district, thereby forcing all 10 of the state's representatives to be from their own party. Now I think you're beginning to see an idea on the effect of gerrymandering. And maybe you're thinking, is there a way to get truly fair and impartial boundaries? And there are. Here's a few mathematical ways that it can be done. So even though there is a way to produce fair and random district boundaries, and even though the Supreme Court, like I said earlier, has ruled many times that gerrymandering is illegal, it's hard to prove, and honestly, it still goes on to this day. All right, that's it. Thanks for watching all about how mathematics can be used to study and make sense of the real world. Contact me via email anytime, or follow me on all the various social media platforms. Thanks again for watching. Bye-bye.